I want to talk about sine rule, the cosine rule, and calculating the area using this new area of triangle formula. So I'm going to show you three problems. The first one's going to be an area problem of a triangle, and the next two problems are IB problems where we have to decide whether we're going to use the sine rule or the cosine rule. So let's jump into it. Let's find the area of this triangle right here. And I want to use this formula, area equals 1/2 AB sine of angle C. You can only use this formula when you've got two sides and an included angle. Remember, an included angle is an angle that falls between two sides that we know. So we do. This 82 degrees is an included angle. In order to use this formula, that angle C has to be the included angle. So I'm just going to relabel this triangle. I'm going to make this C, A, B so that I can plug stuff into my formula. So now that's C, that's A, that's B. So the area is 1/2. Little a is 12. Little b is 7. Sine of 82 degrees. And when I type that into the calculator, we've got 0.5 times 12 times 7 times sine of 82 degrees. That's 41.6. Don't forget that the units are in kilometers squared. So that's pretty simple. That's just how you calculate the area of a triangle using this formula instead of using your base times height divided by 2. Sometimes it's easier to use this formula because to calculate the height of that triangle and then the base, it'd be a lot of work. You're a lot better off just doing the formula here. Alright, let's talk about some IB problems. The diagram shows a triangle ABC. The size of angle CAB right here is 55 degrees. The length of AM is 10, where M is the midpoint. So if that's the midpoint, that means that this has to be a 10 as well. Triangle CMB is isosceles with CM congruent to MB. So what that means is we've actually got three sectors that are 10 here. So those are all 10 in there. Write down the length of MB. Well, I already did that. That's 10 meters because if that's the midpoint, then it has to be the same as that 10. Find the size of angle CMB. Well, this is an isosceles triangle. So that means this is 55 degrees. In order for this triangle to add up to 180, that's 70 degrees right there. Here's the angle we want, CMB, and I know these two have to add up to 180. So angle CMB is simply 180 minus 70, which is 110 degrees. And now we're supposed to find the length of CB, and call that x right there. Now you'll notice that we've got two sides we know, and this 110 degrees. We know a little bit more than that, because I know this is an isosceles triangle as well. So if there's 70 degrees here, that means this is 35 degrees and this is 35 degrees. So we've got some choices. Since we know all of the angles and two of the sides, we can either do the sine rule or the cosine rule. Because we got the cosine rule here because we've got the included angle. I happen to think it's a lot easier to do the sine rule, which is what I'm going to do. So I know that x is to sine of 110 degrees as, let's say, that 10 is to sine of 35 degrees. When you cross multiply, I'll just type this directly in the calculator, we can do 10 times sine of 110 degrees. Make sure you're in degrees mode, which I am. Sine times 110 degrees divided by sine of 35 degrees. We get that side length is 16.4 meters. So CB equals 16.4 meters, and that's the three significant figures. You got the same answer had you done the cosine rule there, but you would have done a lot more work to get to it. I just think in general, if you can get away with the sine rule, it's better to do that. But we can't always get away with it. Sometimes we have to do the cosine rule. So let's talk about that. A boat race takes place around a triangular course, ABC, with AB 700 meters, BC is 900 meters, and angle ABC is 110 degrees. The race starts and finishes at point A. Calculate the total length of the course. Well, I think we can agree, if I call this lowercase b, that 700 plus 900 plus b equals the total length of the course. It's just the perimeter. The question is, how do I find that b? As much as I'd like to do the sine rule here, I can't, because I don't know either of these two angles. And without knowing those two angles, I'm not going to be able to do it. But what I do know is that I've got two sides and an included angle. So at this point, we can use the cosine rule. Now, there are two formulas for the cosine rule. I like to use this one when I'm looking for a side, and I like to use this one when I'm looking for an angle. Since I'm looking for a side, I'm going to use this equation. I'm just going to write it down. A squared equals b squared plus c squared minus 2bc cosine of a. Now the trick here, again, is that the included angle has to be the a. So I'm going to come up here and I'm going to re-letter my picture. That means that this is now an a, this is a lower c, this is lower b. And I'm going to plug in what I know. So a squared, a lowercase a is what I'm trying to find, is 700 squared plus 900 squared minus 2 times 700 times 900 times the cosine of 110 degrees. And this is just calculator work. So let's just type that in the calculator. 700 squared plus 900 squared minus 2 times 700 times 900 cosine of 110 degrees. That's going to give me a big old number that I'm going to write down. That's a squared, so if I want the answer, I just need to take the square root of that. So square root of the answer is 1315.65397.4. If you're going to round that, you need to round it to three significant figures, which would be 1320. But I'm not going to round it. I'm just going to leave it like that. Now, I haven't answered the question yet because I'm supposed to find the total length of the course. So I need to add all three of those sides together to get 700 plus 900 plus 1315.65397.4. The total length of the course is 2,009. Well, when I did the three significant figures, it's 2920, and we'll call that meters. All of that was for part A. Part B says that it is estimated that the fastest boat in the race can travel on average speed of 1.5 meters per second. Calculate an estimate of the winning time of the race. Give your answer to the nearest minute. Well, I can just take the total course length, which is in meters, and divide it by that 1.5 meters per second. And what's going to happen is the meters will cancel out, giving us just seconds. So when I divide that, 2920 divided by 1.5, I've got, and I'm going to do this to three significant figures as well, 1950 seconds. That's seconds, so how many minutes is that? To the nearest minute, you just take that answer and divide it by 60, and we're talking 32 minutes is the winning time. Last part here is to find the size of angle ACB. So now we've got to revert back to the original lettering to figure out which angle they're asking for specifically. And angle ACB would have been this one right here. So to do that, we could use the sine rule, we could use the cosine rule. we know that this side is now, let's call it 1320 meters. So I think it's easier to just go ahead and use the sine rule to do this. So I'm going to say that B is the sine of angle B as A is to sine A. So I'm just going to plug in what I know. And what I know is that this is 700. Sine of B equals the A is 1320 over sine of 110. So when I cross multiply, I'm going to get sine of angle B equals 700 times the sine of 110 degrees divided by 1320, which is about 0.498. Now I'm going to do the sine inverse to get the answer here. Angle B is the sine inverse of 0.498. So angle B is about 29.9 degrees, which is the correct answer there. Depending on the rounding, if you use 1315 here instead of 1320, you get 30 degrees on the nose instead of 29.9. So depending on how you round it, you get a slightly different answer, but it wouldn't be wrong. So the whole point of this is knowing when to use the sine rule, when to use the cosine rule. And I think you're much better off going ahead and using the sine rule when you can, and only using the cosine rule when you have to, because the formula is a little bit more cumbersome, and you're more likely to screw it up. It's a lot easier to deal with proportions instead of dealing with a formula where it's easy to get the letters mixed up. Anyway, thank you for watching. We'll see you next time.